So Zamil Steel I have briefly introduced. This is a 43 years old organization. It is based in Saudi Arabia. The parent organization is Zamil Industrial Investment Corporation, call it ZIC. So they have different industrial arms under them. One is Zamil Steel. So Zamil Steel has 12 production units all over the world, mainly in Middle East, Southeast Asia, Vietnam, Africa, and one unit in India, which is in Ranjangaon, Pune. So our Pune factory has a production capacity of 1 lakh metric ton. So to the product nomenclature, 80,000 is pre-engineered building and 20,000 is structural steel. Now, Zamil Steel offers the full solution, that is engineering, designing, detailing, manufacturing, and erection at site. So our solutions are toward customer requirements. We give whatever customer requires in their building or any structure. So our design and manufacturing and erection suits to that. So coming to certain kind of unique structures, till such time, till last maybe 2-3 years back, it was only PV building system which were manufactured from the plates, and it was much simpler. There are columns and there are rafters and connecting members. For last 2 years maybe, we are innovating and we are designing and manufacturing different kind of structures. This is one such structure we have done for a automotive testing facility in Chennai. This is fully designed through pipe sections, tubular sections. The benefit of this is the member weight becomes lower and the load carrying capacity increases. Compared to the member weight, the load carrying capacity is higher. Weight of this particular member is around 9 tons. This has been manufactured in our Pune Ranjangaon facility, transferred to the site at Chennai, and this is the right side is erected structure. So this is the member which has been erected at site. Similarly, this is a member which is of not a typical PV member. It was for a power grid corporation. Also, the site was also near Chennai. So this was a truss section. It is a combination of built-up section and a tubular section. Another point I want to mention is these members were trial assembled at factory, so that there is no issue at site in assembly. So 2 sections were assembled and then disassembled and then shipped to site, so that it is a smooth erection of the erection team. Similarly, it is a different kind of structure. The beauty of this steel structure is we can go for long span structures. This was a cold storage unit for a cement plant. The span was 78 meters. The was tubular and a cardboard, which made structural light, and we could get the span. So these left side members which was at factory, and the right side it is the ongoing erection at site. Next slide, we have done some here. Earlier, you see the member here, there are components attached to it. So earlier, the components were sent loose to site and was being bolted. So we have innovated and we are welding it at factory. Although the factory work has slightly increased, there are multiple benefits out of it. One is easy erection at site, reduction of requirement of bolts, and frequent of lost at site, because these parts are small. There are many cases that the part at site lost at site. So those cases could have been avoided. So this was an innovation which resulted as a good benefit. This is another kind of member which is called a star or cruciform column. Basically, if you see a building, any factory building, in fact, our factory building is our product. There are certain bracing requirements. So these bracings are put across the columns which restricts the movement in that region. So nowadays, customers are preferring free access across the base in any area. So these types of columns are useful for that, where the basings are not required. And also the beauty of this pre-engineered structure is it is designed for that particular requirement and manufactured accordingly from the flat steel sections. So weight optimization is more. Like this section, if it is manufactured from a standard hot rolled section, UC or UV section, the weight would have been 30% higher. So that's why the requirement or the demand of such structures are increasing. Now, this is also an ideal example of the benefit of a pre-engineered structure. This is a crane beam structure. You can see the structure. It is designed to suit the requirement. The width is higher at one end, and it is almost 50% at the other end. So the design has considered the load factor in the particular areas and designed accordingly. So this is not possible with the conventional method, with the conventional hot rolled structures. Then this is also a built-up rafter beam. Similarly, all the components are attached to it, and it is designed to suit the requirement, not a standard UV section or standard hot roll section. Now, these are certain designs which are lightweight and aesthetically good also. This is particularly designed, the project still going on. This is for a pharmaceutical unit being built up near Pune. So these are tubular structures. These are so it is also aesthetically good. Another part is erected as detailed. So the procedure is first the building is designed. Design is more or less on the load calculations. So they decide the segments. Then detailing decides the actual members and how the building will look like. So the first picture is how the building was detailed. Now the detailing divides the building into parts for the manufacturing to manufacture. Then the goes to site. And detailing also gives site or erection team a assembly drawing, how to erect the structures, which member to be connected with which member. So whatever has been detailed are manufactured and exactly erected at site. Similarly, this is a automatic testing for which the members I was showing. This was the detailed view. This was the erected view. Similarly, a German pump manufacturing company in Pune only. This was the detailed view which was visualized by the design engineers, and this was the erected structure. Similarly, the coal sheds. Now, certain improvement initiatives and innovations we have gone into. One is solar power. We have installed a 1 megawatt solar plant in our rooftop, and it is operating since 1 year now. Not only we are saving on electricity, but it has definitely reduced the carbon footprint also. And with this, we have partnered with this company also, and we are providing retrofitting of solar plant on our customers' rooftop also. Now, before going to the next part, I'd like to discuss why steel in construction. So there are certain definite benefits. One is lightweight design. Another is long span solutions, which we have already seen. Repurposed solutions. If you want to change, expand the building, it is easier. Architecturally exports, certain kind of architectural designs can be given, which is visually aesthetic looking, and speed. Definitely, it is faster in construction cycle time compared to conventional construction. Another point which is not mentioned here, which is not technical, that is abundant of availability of steel. In India, the steel plant are manufacturing roughly 150 million tons of steel in a year. So that's why now there is no alternative of steel structures could be invented. So we are working on optimizing, keeping steel in mind. So we are working on grade of steel and designing of steel. Grade of steel, typically, yes, we are and everybody is using E350 grade, I062 E350 grades for the structure purpose. We have worked substantially with Tata Steel and we have made our process ready to process E450 grade steel, which is the higher one than the E350 grade steel. Now design is taking up. So this way the building will be lighter because E450 grade have higher strength and yield capacities compared to E350. Also, the photograph shows how we are optimizing the designs. You can see the flange of a member, which the width of which is varying as per the load requirement. So in a single member, the width is varying. Also, it is not clear in the picture, but the thickness of the plate is also varying. So we are optimizing whatever way it is possible. We are reducing thickness where the load concentration is less, and we are reducing the width also of the members where the load concentration is less. Now, this is one point I'd like to highlight, that within this difficult time also, we are looking towards the future. This is a beam drilling line, CNC beam drilling line, fully automatic, manufactured by world company called Cantorbeck, Germany. So we have ordered this. It is expected by January. So this will eliminate many manual activities what we are doing now. So holes will be drilled automatically and the dimensional accuracy will be extremely perfect. These are certain process improvements or innovations we are thinking of. In a structural member or a building, steel building, there are certain members which are majorly load bearing. There are certain members which are not load bearing. For joining those members, we used to use the similar or the same welding process till now. Now we are switching over to the spot welding technique, which were already available. We have done the trial, we have done the testings also. So we are adopting these techniques where the load carrying requirement is less and the spot welding can give that requirement. This will make the process faster. This will reduce our cost and this will also look aesthetically better. Similarly, there are certain kind of members. There is very nominal load on them. Typically, the covering of member, there are sheetings and there are flashings. So those members, till now we are joining by riveting. Now riveting is a time-taking process as well as a costly process. So this alternate solution, alternate method is still under discussion. We are discussing with 3M India. They have some kind of adhesives which can join structural members in sections. Few of the members, this solution is already successful. We are going ahead with that. And few other members, 3M is already working to upgrade their already available product so that it can suit our requirement. Now, other than those related to the process and product, we have in mind about the automation initiatives also. So there are two parts. Hard automation means in our kind of industry, handling is a major non-value-adding activity. So to use that, we are thinking of automating our handling processes, as well as there are solutions or options available of robotic welding and robotic assembly of parts. Yes, there is considerable amount of cost involvement. So we are working on this, but definitely we'll be moving toward this in next 3 to 5 years. Another soft automation, we have already started working on this, data digitalization and IoT. So already we are working with a company called Nitor. So we have decided a pilot of quality control so that our inspection can be automatized or not. So that project was about to start, but that is delayed because of the disturbance caused by pandemic. But we'll start this very soon, and we'll gradually go towards the IoT and Industry 4.0. This is the last slide, not the least. I'd like to speak few words on this. This is very well known to all of us how this pandemic and subsequent lockdown has created, disturbed not only the industry in day-to-day life, everything. So our factory was already told, factory was closed for only 1.5 months. Not only factory, our site activities were also closed. Only we could run some activity related to our engineering, design and detailing could be done working from home. Now, subsequent to the lockdown, we opened on 4th of May. And it was a panic, definitely. First, we did all the precautions that were necessary. We took that. What guideline was there from the governments, that was taken care of. And as Dr. Ujjwal was saying, we also took care of our employees. There was no pay cut. Everybody was given confidence. All the precautions were taken. If somebody was feeling not well, he was asked to take rest at home. So everything was taken. HR part, precautionary part, and definitely the meetings have become virtual. And it took us time to re-establish our operations. Fortunately, we had orders, and since our design detailing team was working from home, we had the drawings also to manufacture. We had the raw material also. The major issue we faced was availability of skilled workmen. We have few skilled contractors who are working in our premises or skilled level. That is well-known fact. Who took time to come back to our factory? So when we restarted the factory on 4th of May, the attendance of workers were only 11 workers were there. Before this lockdown, 700 workers were coming to the factory, plus minus 5-10%. We started the factory with 11 persons. And fortunately, it went up to the 25% of the capacity within 2 weeks of time. Then after, and it took almost 4 months or 4.5 months, bring it to the normal stage. So for last 2 months, we are working almost normally with all the precautions on, and the effect of pandemic which was there is going as far as the operations of Zamil Steel is concerned. So this was all my part. These are few of the missions